allowed me access for the first of these online meetings that you are going to have. Can all of you hear me? Would you just verify whether you can hear me?
Yes, ma'am.
Yes, ma'am. Yes, ma'am. We can hear you.
Okay, good. Well, I'm glad to see that some of you have joined, and I welcome you to this course on fundamentals of protein chemistry. And during this course or during whatever lectures you will be attending during the curriculum that we have designed for this course in the different modules, I believe you will have a good feeling about what protein chemistry is all about and how it actually governs our lives in every aspect. So what we have tried to do is cover these different modules related to motor proteins, to membrane proteins, and every different aspect, talking about enzymes and so on and so forth. So I believe my excitement about proteins that I've been working for over 30 years will probably be percolated to you. What I will do now is Karan is our Prime Minister Research Fellow. Okay, he is a PMRF, very prestigious fellowship that he has got, and he will be guiding you through every week the modules that we are going to be covering, the lectures for every week, and he has prepared a set of slides, presentation that and a set of questions also that are going to guide you through the type of assignments that you're going to see and the type of questions that are going to come for the exams that are late in October. So if you have any questions related to the course, you can guide them on this platform to Karan or to the discussion forum where we have 3 other TAs who will be taking care of you as you go along. So there are 5 of us who are going to take care of you in this course, and we hope that you will have a fruitful session. Okay, Karan, over to you. I'll take leave, and I believe you can now present yourself and also interact with our students here.
Thank you so much. Thank you so much, ma'am, for very lovely introduction. And hello, welcome everyone. Welcome to this live interaction on fundamental of protein chemistry. I am Karan Kumar, PMRF scholar at School of Energy Science and Engineering, IIT Guwahati, and I will be taking your live sessions for this course every Friday, 7 to 8 p.m. So, and this live interaction will be very fruitful for you to sail through this course, and I will be guiding you how to solve the problem which are there in the assignment, and also which will be for the upcoming modules and other for examinations, your final year examination also. So let me share my screen and let me begin with the slides that I have prepared. I hope you all are able to see my screen. Please confirm.
Yeah, sir. Okay, sir.
Okay, thank you. So as we all know, this discussion is for the week 1. You can see my week 0 assignment discussion on my YouTube channel that I will be sharing, and also this recording will be also uploaded on the YouTube channel. I will be sharing my slides also on the Drive link, which will be shared to you by NPTEL team. The concept that were covered in the week 1, as you all must have seen, was through the lectures of module 1. So the basic terminology and keywords that were covered in the week 1 was amino acids, chirality, non-polar and polar characteristic of protein, hydrophobicity, then chromophores and peptide bonds, planarity, and rigidity. So these were the important keyword that you must have come across. So I will be discussing basically the questions, and these questions will not be related to your week 1. That assignment you need to submit it, but I will be basically taking the overall the content of week 1 in few questions that that I will be presenting next. So here the first question is, which which of the following sets contain all aromatic amino acid residue? And your options are option A, G, D, and E, B, F, Y, W, C, R, K, H, D, I, V, L, M. Okay, so you must have seen this question in the assignment also. Then the following questions are designed on that set of like whatever questions you are having in week 1. So as you go through these questions, like for these 4 questions, like identify the amino acid containing non-polar aliphatic R group. Options are glycine, alanine, leucine, phenylalanine, tyrosine, and tryptophan, lysine, arginine, histidine, serine, threonine, cysteine. Then the amino acids that are amino acids having R group with negative charge at PS7 are cysteine and methionine, arginine and histidine, aspartic acid and glutamic acid, proline and valine. Your question 4 is which which of the following have the most chiral center? Which is your options are isoleucine, isoleucine, serine, tryptophan, and threonines, and options are given as follows. And another set of questions, 8 questions are given in, and these all 8 questions focus on the amino acids, its property, its characteristics. So can somebody answer these questions? And then I will be going for the discussion session and how to solve these problems. And then I will be going through like how to approach these problems. And if similar questions is appearing, how you can remember those techniques. So few mnemonic techniques I will also give. So before that, can somebody answer these questions, unmute themselves and answer these questions? Anyone?
Sir, question 1, answer D, FYW.
Okay. Another one, option question 2. You can also use the chat box which is given there, and that is I guess that is accessible to all of you, so you can use that also. Answer for question 2. Then for question 3, what is the correct answer? Can somebody unmute themselves and answer that? Okay, question 4. I will be giving around 2 or 3 minutes to you. If you have something to say about these questions, you can answer, or else I will start discussing about it. How to approach them and how to remember them, any few techniques to memorize them or to understand them, what can be the, or to guess what can be the correct answer, because these questions you will encounter in every kind of exam, like any competitive exam, either in gate or you write net or anything you write. These kind of questions will be there in your competitive exam. So try to try to peel through these questions and then try to answer these questions. Anyone? Question 5, 6, 7, 8. Eighth one is, I guess, very easy. You can answer it. Anyone? Okay, so let me go through the strategy to solve these kind of questions. Okay, so the first question here, if you have gone through all 8 questions here, you must have seen that you need to remember few of the things. That is, what kind of amino acids having the different kind of characteristics, like hydrophobic, hydrophilic, what nature they have, either they are polar, non-polar, or you need to also remember the one letter code, right? Okay, so one letter code you need to remember. Then another things that I can point out, you can also remember three-letter codes. Three-letter codes are easy, but one-letter code is bit tricky to remember, but I will tell you how to remember that. Then you can, for answering this question number third, you need to remember the how the chain, side chain is appearing, like what is the nature of side chain. If you have gone through the lectures that ma'am had taken in the module 1, there also she has specified that you need to focus more on the side chain of the amino acid, because the backbone is almost constant everywhere, but you need to remember the side chain. And that will, if you remember the property of side chain, then it will be very easy to answer these kind of questions. So the question number 3 and question number 4, that basically that depends on the, if you remember the side chain of these amino acids. Then question number 5 is mostly related to the polarity or non-polarity, and then this is also related to the side chain. Then so now coming to the explanation of these questions. To remember these questions, like to remember these amino acid characteristic, the very easy technique to remember non-polar hydrophobic aliphatic side chain. Please take a note that whatever I will be discussing here, that will be related to the side chain. The properties are dependent on the side chain, because amino acids, all amino acids have common in the carboxylic acid. They all have the carboxylic acid in their structure, and they all have the carboxylic acid attached to its alpha carbon. Here the alpha carbon is this one, and amine group. They all amino acids have this characteristic and one hydrogen. The variation is due to the side chain, which can be seen here. Like it is the alanine. Alanine have only CH3 as R group. Then valine has this one. Then methionine, the side chain for methionine here is this one. Okay. So now to remember this is for this technique. This mnemonic technique is for non-polar hydrophobic aliphatic side chain. So to remember them, you can recall a vampire girl, and you have phobia of them. Okay. So the technique is phobia of vamp girl. Here, all the letters in vamp and girl will remind you the different amino acids that will have the non-polar hydrophobic aliphatic side chain. Okay. Phobia represents hydrophobic. Here V represents valine. The structure is given here. Then A represents alanine. M represents methionine. P represents proline. An important feature of chlorine that it has the imino group as side chain. This is called imino. Okay. Now glycine, then isoleucine and leucine. So phobia of Vamker, to remember non-polar hydrophobic aliphatic side chain, where valine, alanine, methionine, proline, glycine, isoleucine, and leucine. Here R does not represent anything, so don't confuse with that. Now your second technique to remember the non-polar hydrophobic aromatic side chain. To remember them, you can imagine a pine and timber tree and aroma of those. So the mnemonic technique is aroma of pine and timber tree. Okay, here aroma. Why aroma? You can recall these are for the aromatic. Then pine and timber tree. P here represents for phenylalanine, T for tryptophan, T for another T for tyrosine. Okay, so now the important features here, what you can see, the tryptophan here, it's the bulkier group, right? it has the bulkier side chain, and all three have the aromatic rings in it. Okay, aroma of pine and timber tree. Then I will be discussing the chiral center and all. Let's first focus on what is the chirality. Okay, so anybody unmute themselves and answer, because ma'am has discussed the chirality in very good, like very great details. So can somebody answer what is chirality? Unmute themselves. What is chirality?
When all the groups attached to the central carbon atom are different, that carbon is the chiral carbon, and the terminology is chirality.
Okay, may I know the name? Who is answering this?
Sarika Kulkarni.
Great, Sarika. Very good. You have answer, like, so your answer is correct. Chiral center is that carbon. There you also denote that carbon in convention as C alpha carbon, and the all four, because carbon has the four like four valency, so four groups will be attached to it. Therefore, if all four groups attached to it, either groups or any atom, group of atom attached to the carbon, then and all four are different, then those are termed as chiral carbon or chiral center. Okay, so if you see in all type of structure that are appearing here, they have the chiral center, but except which can somebody answer which amino acid does not have the chiral center? Which lacks the
Glycine.
chirality? Which one?
Glycine. Glycine.
Glycine. Which one?
Yes.
Glycine.
Yes, sir.
Okay. And you can somebody tell how it is different? This is glycine, right? Okay.
Yes, sir.
Because two valencies occupied with carboxylic acid and amine group, and another two is hydrogen. Okay. So that is why glycine is not chiral, and it is also termed as achiral. Okay. So here, so can somebody answer which one in this have more than one chiral center? Another thing. Let me tell you the
Sir,
convention how to name. First one is alpha carbon, which is chiral center, and then another carbon which is attached to it. Then we can rename them as we can name them as carbon beta, then carbon gamma, like that. Okay, so can somebody answer which of these amino acid have more than one chiral center? Sorry,
sir,
I
it's
interrupted someone.
isoleucine
Yes,
and threonine.
isoleucine and threonine.
And
Okay.
threonine.
Okay. Threonine structure I have not given here. Threonine will be in the next one. Very good. Isoleucine and threonine both are having the more than one chiral center. As you can see, first one chiral center is this one, because it has this group attached to it. One side, another side NH2, another side COOH, and one is hydrogen. So this is first chiral center. And another one, if you come here, one is attached CS3, another is attached this whole group, then this group, and one hydrogen here. So it has two chiral center. Okay, very good. So now coming to the next classification to remember polar neutral hydrophilic side chain. So you can remember them by come take gas. Okay, come take gas is the technique to remember polar neutral hydrophilic side chains. So here C in come represents cysteine, T in take represents threonine, then glutamine, asparagine, and serine. Okay, so you can also remember these all side chains that are attached to the alpha carbon. Here cysteine has SH group, sulfur group. Then threonine has another chiral center here. Then glutamine have can somebody tell which group it is that I have marked here? Which group it is? Glutamine. You must have studied this in your chemistry, like your in 10th or 9th, where you must have studied the functional groups. So which functional group it is?
Amide group.
Good, very good. So only two amino acids have amide group in their side chain, and those are glutamine and asparagine. To remember the difference between glutamine and asparagine, they glutamine have one extra carbon in their side chain. Okay, as if you attach a carbon CH2 group, CH2 in their side chain, then you will result as a glutamine. This is this I told you to remember the structure, which one is bigger and which one is in shorter in their side chain. And another important thing to note here, serine has hydroxyl group, OH group attached to it. Okay, so to remember polar neutral hydrophilic side chain, you can remember that by come take gas. Okay, and you can imagine you are going to a gas station and the vendor there, they are telling you come and take gas. Okay, so here these all 5 amino acids are polar neutral hydrophilic side chain. Now can somebody tell me why these are polar amino acids? Why these are polar? Can somebody tell me? Why polarity arise in certain type of compound? What is the origin of polarity? Can somebody unmute and answer this question? You may be wrong, you may be right, but try to, because this is an interactive session, right? So that is why I am trying to make it make the interaction happen. Otherwise, the watching through the YouTube and other lectures, that is always there. But I am trying to make this more happening. That is why I am asking the questions again and again. You may answer that may be wrong, that may be right, but that will build your confidence. Why polarity arise in certain type of compound? Okay. Polarity
Maybe
mostly
due to
arise.
the
Yes.
electronegativity.
Due to
Maybe due to the electronegativity difference.
good, good, very good. Because of presence of the electronegative atoms in the structure, or in terms of amino acid, if I am talking about, then the presence of heteroatoms such as sulfur, oxygen, nitrogen. The presence of these atoms makes certain certain amino acid more polar. Okay, what is the major difference in this amino acids and this amino acid is they have sulfur, they have oxygen, they have nitrogen in their side chain. However, these hydrophobic amino acids, they only have the carbon except proline. Proline in amino, and this NH is also the part of the backbone, which is the functional group. So you also will not consider this as a presence of heteroatom because it has only the carbon. Only the exception here is methionine. It has sulfur atom, but it is hydrophobic. Then next, tyrosine. Among the non-polar hydrophobic aromatic amino acid that I have discussed here, these three, among them only tyrosine have the polarity and it is partial hydrophilic. So, but to remember the aromatic amino acid, I have listed these under the same convention. Okay, but remember tyrosine is hydrophilic because it has OH attached to it, side chain. Okay, so very good. Now coming to the next mnemonic technique to remember amide contained side chain that I have already discussed in the previous slide, and those are amide contained are the glutamine and asparagine. Okay, glutamine and asparagine both have the amide group in their side chain, and hydrophilic negatively charged side chain are glutamate and aspartate. Okay, here glutamate and aspartate, they both have the extra carboxylic group attached to their side chain. Okay, and I will also give you a trick to remember the side chain property, like wherever you are transferring from A to G, like not in all case, in this case I can see the difference that glue contain acid, which is for the both trick for amide containing side chain and hydrophilic negatively charged acidic side chain. You can see if for S letter that are starting with A, asparagine and aspartate both have only one carbon chain. Like here in their side chain they have CH2 group, and if you are adding one more CH2 group in this structure, that will convert to the G. Okay, A to G. So you can remember that you can remember like this from asparagine to glutamine. Glutamine, if you are going, then you have to add a extra CH2. And here also, if you are going from aspartate to glutamate, you have to add a extra CH2. These techniques I am just telling you to remember very easily. Okay. Another one, alcohol tastes sour, is to remember the alcoholic side chain. Alcoholic side chain are threonine and serine. Both have the OH in their group. Okay. Serine. Here it is serine, and then threonine was in the threonine. Here they have the side chain. Okay. Now next, coming to the another technique to remember sulfur containing side chain, which is supply chain management. Supply chain management, you can remember this technique is for supply stand for sulfur containing, then chain C represents here for cysteine, and in management M represents for methionine. Okay, so only these two amino acids have sulfur in their side chain. Okay, here in methionine and here in cysteine. Your last mnemonic technique to remember hydrophilic positively charged basic side chain. Okay, and you can remember that by last action hero. So you can recall such as last action hero movie gave the positive message. You can remember like this. Last action hero movie gave the positive message. So, and this technique will be for hydrophilic positively charged or basic side chain. Then this here L represents lysine, A for arginine, H for histidine. Okay. Why they have positive charge? Can somebody unmute themselves and tell why these three amino acids have positive charge? Lysine, arginine, and histidine.
Because they have extra amine group in their structure.
Very good. Very good. Because they have extra amine group in their structure. So, yeah, these all heavy nitrogen atoms attached to it, their structure. Okay. So by this, you are coming to an end of the mnemonic technique to remember the amino acids and property, and another mnemonic technique to remember essential amino acid. These the question on essential amino acid comes in almost all kind of exam. That is why I have listed here. There are total 10 essential amino acids, and amino acids. Can somebody unmute themselves and tell what is essential amino acid and what are non-essential amino acids? Definition, not the amino acids that are present in them. What are essential amino acids?
Which we have to take in diet.
Yes, and because they are not made in our body,
Essential
and we
amino
need to take
acids
them.
are the amino acids
Yes. Go on.
are the amino acids that which are not produced in our body. So we have to take them through our diet.
Very good. Okay. So to remember them, the very short technique is to private timber hall. So you can remember a hall where the timber facility is going on, and that is private. Okay. So here private timber hall will represent all essential amino acids, and it includes phenylalanine, valine, threonine, tryptophan, isoleucine, methionine, histidine, arginine, leucine, lysine. Okay. Now coming to the question number 1 to 8. And now can you answer this question? Okay. So first one already answered. Which of the following set of, I will also go through the how to remember the 1-letter code or 3-letter code that are the next in series. So let us first discuss this question. So all aromatic amino acid as we have gone through, F is representing phenylalanine. Y is the short 1-letter code for tyrosine, and tryptophan for W. So correct answer is B. Okay. Then identify the amino acid containing non-polar aliphatic R group. And you must recall the technique that I have discussed was phobia of Vampker. So phobia of Vampker will contain non-polar aliphatic R groups. So here L, A, H. Okay. So the correct, phobia of Vampker. Sorry, this is not the answer. Vamp girl. Okay. Here, if you go, this is R. If you go glycine, alanine, and leucine. So correct answer is A. Now, 2 amino acids having R groups with a negatively charged at pH7. Now tell me why negative charge appears. Negative charge appears due to COOH group, right? And positive charge appears due to amine group, right? NH2, presence of amine group in their side chain. So 2 amino acids that have the COH group, which will be aspartic acid and glutamic acid. So correct answer for third is C. Now, which among the following has or have the most chiral center? We have discussed this in the slide, slides. Here, the correct answer is, as somebody had already answered it, which is correct answer is D. Isoleucine, because it has branched chain, and threonine. Okay. Next question. Choose the correct statement. Tryptophan and tyrosine are more polar than phenylalanine. Leucine is commonly used as ingredient for buffer of HDS page. Aspartate is a beta branched amino acid. Lysine is an amino acid with imidazole group as side chain. Now, to eliminate the answer, like imidazole group are present in histidine. So this is not the correct answer. Now, aspartate is a beta branched chain. Is it? No, because it has only CH2COOH. So it is not beta branch. So this is also a wrong answer. You will be studying in the molecular biology lab that leucine is not used in the SDS space. So this is also wrong. Your correct answer is tryptophan and tyrosine are more polar than phenylalanine. Okay. So which of the following is an amino acid? While discussing the mnemonic technique, I also mentioned that proline have the amino group in it. So correct answer is B. Which of the following is not sensible grouping of amino acids based on their polar properties? Okay. So for polar, what was the technique for polar? Can somebody unmute and tell? For polar side chain. Your correct answer is aspartic acid, isoleucine, and proline. Okay. This is not sensible. Remember it. This all contains a few. Which of the following is not a sensible grouping of amino acids based on their polar properties? And your correct answer is C. Now, the correct one-letter code for tripeptide ASN, TYR, lysine. As the name says, this is asparagine, then tyrosine, then lysine. And for asparagine, the correct letter is N. For tyrosine, the correct letter is Y. For lysine, the correct letter is K. So your correct answer in this question is NYK. So we have discussed the 8th question. Now coming to the, as I have promised that I will tell you the 1-letter code and 3-letter code of amino acid and also the class. In this table, you can see the hydropathy index, then their molecular weight, then genetic coding. What are genetic coding? Genetic coding is those 3-letter codon which represents a particular amino acid. You must have studied in your molecular biology class that when you are transcribing the DNA to make mRNA, then in the transcription stage, there the 3-letter codes, that every 3-letter code codes for a particular amino acid. So these are the genetic coding that represents particular amino acid. Okay. This table can be beneficial for you for remembering them in the next, like in your further competitive exams and other in your final exam or somewhere. Okay, wherever you require it. So here I will tell you that the main focus is histidine. It has 10% positive nature and 90% neutral nature, and this property is very much important when you will be seeing that histidine have in their side chain, if they have in their environment, if they have positively charged amino acid residue or negatively charged amino acid residue, then the property of histidine varies according to that those environment. Ma'am has also discussed that in the her discussion lecture, which was lecture number 5, and I will also discuss that because that is very important. And then you can remember the 1-letter code by in a series fashion, like ABCD. You all know the ABCD, right? So there you can remember them, like alanine codes for A for alanine, then no amino acid is for B. Then you come for cysteine, alanine A, cysteine C, then aspartic acid. You need to remember this because it has variation. Because A is already assigned to alanine, so aspartic acid is for the D, aspartate or aspartic acid, anything you can tell. Then glutamate. Another important thing to remember is glutamate. 3-letter code is GLU and 1-letter code is E. Then phenylalanine or F. Then glycine is G, histidine is H, isoleucine is I. Then another one is lysine for K. Okay. Then leucine for L. Coming to the next, methionine M, asparagine N. Okay. Proline P, glutamine is Q. Arginine R, serine S, threonine T, valine is V, tryptophan W, tyrosine Y. Okay. Hydropathy index is also mentioned here, and hydropathy index shows how much hydrophobic side chains they have, like particular amino acid. And this hydropathy index is very much important in sense of when you are trying to understand which amino acid will come into the pocket, which amino acid will face the solvents. So to understand those kind of concept in protein folding, you need to know the hydropathy index of those amino acids. Then you need to remember the side chain, then their properties. Now, this is the important slide for remembering the pKa. Only few of the amino acid in their side chain have certain type of pKa value because they contain either nitrogen, either sulfur, either COH or OH. Only those, because of them, they have the extra pK value. Otherwise, you will see most of the amino acid, they fall around, they have the pK value 1 for COOH that comes around 2, and NH for NH2 pK value that comes around 9. Okay, you will see that in this slide. And also here it is given as the 3-letter code and 1-letter code. Then you can remember this to calculate the final PI of a protein or a peptide or the dipeptide, tripeptide, any combination. So for that, you need to remember the pK value of amino acid in terms of amine group and carboxylic acid group. And for some of them, you need to also remember the R group, pK value of R group. Now, your 9th question. Tell me what is isoelectric point of an amino acid. Then if pK1 is 2.3 for particular amino acid, pK1 for 2.3 and pK2 for 9.6, then what would be its isoelectric point? Then when amino acid alanine, which have the R group CS3, is added to the solution of pH 7.3, alanine occurs as in which form? Then your next question is alpha amino acids, a carboxylic group of pKa around what? And for amino group, which is the correct option? Can the 12th question I have just discussed it? What will be the correct answer for 12th? That will be the A.
Option A.
Okay. For our question number 9, what is isoelectric point?
Option
Can somebody
A.
answer? Option A.
Option
Which
A.
is pH where the molecule carries no net electric charge. Very good. For 10th, can somebody
5.97.
directly calculate it?
5.97.
5.87.
5.87 or 5.97?
5.97.
5.97.
I have 2 answers for this. Any other answer? 5.87, then 5.97. Any other answer? Anybody with 3.7 or 11.94? How to calculate the PI value? This is your question. Okay. Let me first come to the question number 11. When amino acid alanine with R group as CS3 is attached to a solution of pH 7.3, alanine occurs as which form? So basically the question is, if alanine is submerged into a solution of 7.3, when the surrounding the pH is 7.3, what will be its nature? Like how it will appear? Either will it appear deuterium, then cation or anion or isotope? What is the correct answer for this? The correct answer here is deuterium. Correct answer here is deuterium. Okay. So all to this now, what is the common in all these four questions? All four questions, what is common? You need to understand the concept of isoelectric point. What is first thing? What is isoelectric point? Then another thing, what is deuterium? What is the how to calculate the pi, and how certain amino acids changes their behavior in presence of different pH, and why it is happening. So if you know this concept, then you will be able to answer particularly these kind of questions. Okay. Now the equation, the thing to remember how to calculate the pi, you need to add both of the pKa1 and pKa2 and take the average of it. What will be the pKa1 value and what will be the pKa2 value? That is particularly dependent on the particular amino acid, but in polypeptide chain that varies. If you have a dipeptide or tripeptide and any other combination of amino acids, then to calculate pi value, you must remember the transition from charge from +1 to 0 to -1. Okay. If you need to note down which pKa turns the amino acid from +1 stage to neutral and then neutral to negatively charged, those pKa, if you add up them and divide them by 2, then you will get the correct pi of particular amino acid or any peptide chain. Okay. Currently, there are many server available. People like software people have developed certain kind of software where you put the sequence of amino acid and then they will predict the correct pi for you. And but how this can be done? So the basic fundamental behind this to calculate the pi is the transition from +1 charge to neutral and then neutral to -1. Where you take these charges, you take the average of these two pk value and then you get the pi. Okay, why particularly this? Because as we already discussed that deuterium is the net the value where the net charge is 0. So just before the pi value and just after the pi value, if you add those pka values, then you will get the pi. Okay, and you can understand that why this particular graph. The x-axis represents here pH and y-axis is the concentration of particular amino acid. So in solution, when you put in a pH of 0, the most of the amino acid they have the pK1 value. pK1 is for the ionization of carbon, this one carboxylic group attached to the alpha carbonyl group. Then this is the first pK, and we have already discussed that this approximately it comes around 2, and another one that comes around the pK value for amine group that comes around approximately at 9. Okay, so you try to understand this situation. If you have any amino acid, this is general amino acid, right? Because the side chain is R. Okay, if you put them into a solution at low pH, then mostly it will be in the which group? Both groups will be a protonated state because pH is the inverse of H plus concentration. If it is low pH, it means it has the high H plus concentration, high hydronium ion, high protons. So when in environment there will be more protons present in the solution, then both of the functional group, obviously they will be in the protonated state, right? So that is represented as this magenta line or pink line. Okay, so in the low pH condition, deuterion will be very less. There will be no deuterion to somewhat extent if the amino acids have the pK1 value of that particular amino acid is lower, then they might exist in some part of the deuterion form. Few of them, not all. Okay, but after the first pK1, this is the first pK1. You see that the both protonation state tend to decrease. Those concentration tend to decrease because after the first pK1, the proton of this alpha carbonyl carbon, that the carboxylic acid attached to the alpha carbonyl carbon loses its proton at its pK1 value, and then you will have a deuterionic form, or you might be having deuterionic form, or you may not be having deuterionic form. Okay. Am I correct or am I wrong? After pK1, will you see the deuterionic form or not? What is deuterionic form? Can somebody unmute? Okay, let me answer this question. First, here in the side chain, if you avoid the presence of side chain, only if you only focus on the alpha carbon carbon, in this stage, what is the charge? It is +1 charge, right? So this +1 charge will be neutralized only when the this carbonic acid attached to the alpha carbon, not carbonyl carbon, sorry. So alpha carbon, this carbonic acid, if it loses its hydrogen, then it will have a negative charge. So negative and positive, net charge will be 0. So this is the deuterionic form. So after pK1, you will see the increase in deuterionic form. Okay, and your both protonation, the amino acid which have the both protonation, that concentration of those particular amino acid will decrease, and there will be a range where you will see most of the amino acid residue or protein in its deuterionic form, where the net charge will be 0, but amine group and carboxylic carbon may have the will have the charges on it. And don't forget, the side chain also have amino acids. Side chain also have the COH or COH, then OH and other heteroatoms that may be the presence of charges in their side chain. So, and after your pK2 value is represented as when your the amine group attached to the carbon alpha carbon also loses its proton, because why it is happening? Because pH is increasing, right? pH is increasing, and pH is what is the formula for pH? pH is minus log of H plus, right? Minus log of H plus. It means the pH is increasing. When pH is increasing, then it has the reverse relation, means protons concentration of proton is decreasing. Concentration of protons is decreasing. That is why this amine group attached to the alpha carbon, that will also lose its proton, and both group will be in the deprotonated state, and finally you will have the negative charge because of the carboxylic acid, which is already protonated at the pK1 value. So this is the basic mechanism how the pH changes the charges on amino acid. And this, can somebody tell which amino acid it is? This example I have given to show you the influence of side chain. Okay, tell me which amino acid it is. Can somebody unmute and identify?
Sir, may you please repeat the question once again?
Okay, my question is which which is this amino acid represented here? Which is this amino acid? Can you identify it based on the side chain?
Lysine.
Very good. This is lysine. And now coming to the protonation states, if I see that more technically, it is the titration. You must have studied that in the lectures and you have come across the concept of titration. So if you are titrating lysine, then how the charges will how the charges will change, and what will be the pi value of lysine during titration. So here, if you see that at the low pH value below 2.2, the first pK1 is for the carboxylic acid of alpha carbon. So below pH 2.2, the protein will exist in charge +2, right? Because it is here +1, +2, and carboxylic acid does not have any charge, right? So before its pK1, where the proton pK1 is where the carboxylic acid of alpha carbon will donate its proton, release its proton. So before that, the protein will exist with a net charge of +2. But at pK1 or after pK1, means the pH, when it increases after 2.2, the carboxylic acid will donate its proton. And the net charge will be +2 -1, that will be +1. Okay. Now, the next thing that will donate its proton will be its side chain, not the amine group of alpha carbon. Okay. So at pH value of 9, the side chain amine group will donate its proton. Am I right? You must interact with me, or if I am wrong somewhere, if I am stating something wrong, you interrupt me. The side chain amine group will not donate its proton at lower pH. Okay. The second donation will come from the amine group of alpha carbon, and then the protein will come to a neutral stage. Here the protein net charge is 0. So +1, 0, and then the second pK2. Second pK2 is for the R group. Then R group will release its proton, and then you will have a net charge of negative -1, right? So +1, 0, -1. That means you need to calculate the pi of lysine from these average of these two pK value, not pK1 or pK2. Okay, so your pi will be the average of 9 plus 10.5 divided by 2. So that will be the pi of lysine. Okay, this is an important aspect of presence of side chain. Okay, that I have discussed. Now, coming to the very important aspects that I was discussing about in the beginning of my presentation about histidine. Histidine is the kind of amino acid that changes its pi value also. Like the pK value, pK means the pi, isoelectric point of this histidine side chain. Normally it falls as pKa of 6. But pKa of 6, it means it is talking about the side chain, means imidazole group that are present in histidine, imidazole group. the important feature of this imidazole group is what? It helps in retaining the charge of amino acid because it has the lone pair and it has a proton also attached to it. You will see histidine in many of the catalytic site of proteins, like in lipase also. In wherever you see the catalytic amino acid residue, group of catalytic amino acid residue, you can guess histidine might be one of them because of its very important feature, because it changes its pKa value and it ranges around the physiological pH. Okay, its pi value, because here the side chain of pKa, side chain side chain of the imidazole group, it tends to retain its proton when it is surrounded by the positive charge amino acid residue. Am I right? No. See, when already positive charges are there in the side chain, in the surrounding amino acid, not in side chain, surrounding amino acid, then then this imidazole group will release its proton because already there is a positive charge, right? But when it is surrounded by uh, negatively charged amino acids in the then the imidazole group will tend to have its proton in its stage, right? So in the negatively charged condition, they will have the larger pKa value greater than 6, and in the positive charge condition, when their environment are positively charged, they will have the lower pKa value. They will release the imidazole group will release its proton lower than its pKa value, which is 6. Okay. Now coming to the next question. Which pair of the amino acid absorbs the most UV light at 280 nanometer? Okay. So here your options are tryptophan and tryptophan and histidine, phenylalanine and proline, tyrosine and aspartic acid. Now I will discuss this.
Tryptophan and
Tryptophan and what is the
tyrosine.
answer? Good.
Tryptophan and
Option A.
tyrosine.
Okay. So next question is, among the following, which is the following the correct about the absorption spectra of amino acid? I will come to this question later. If you are able to answer, that is good. Then a buffer solution is prepared by the mixing 1 mole of HA. HA is the weak acid here. Then 1 mole of Na. NaA is here. You must have come across the concept of acid, weak acid and its conjugate base. So Na is here the salt of its conjugate base. Then it is dissolved in 1 liter distilled water. Then calculate the change in pH when 25 ml of 0.2 molar NaOH is added into the 500 ml of the buffer. Okay, and given the Ka of this weak acid is 1.75 into 10 raised to minus 5 molar. So I will show how to solve this problem in step-by-step manner. Then your next question is, a buffer is prepared using 1 molar HA and 1 molar Na, where the A correspond to the anionic group. pK of HA is 4.87. The pH of the resulting solution is which of this? Okay. Now first let me discuss about the question. Now we have already now coming to this question, like the first one here is pathochromic and about the pathochromic and polarity, hypochromic, and then now first let us discuss about the absorbance phenomena. Why absorbance happens? Why does certain compound absorbs the UV radiation and emits the light? So here what you see, like the normally absorptions happen due to the presence of the electrons that have the like if you have studied the molecular orbital theory, in molecular orbital theory what you will see, the occupied orbitals will be like sigma bonding, pi bonding, then non-bonding orbital. After that, higher in energy will be pi star antibonding and sigma star antibonding. So if electrons are filled up, okay, electrons are filled up there. So few of the atoms, the electrons and the few of the atoms, if they absorb the light either in the UV range or in visual range, and they takes the energy, and then they make the transition from lower energy state to higher energy state. So in that phenomena, when they absorb the light, then that particular phenomena is measured in a kind of instrument which is called UV visual spectrophotometer. Okay, so in UV visual spectrophotometer, if certain particular wavelength is absorbed by the atoms, and then they tend to have some kind of color, they will show some kind of color, and they are termed as chromophores. Okay, and that mostly arise due to the pi electrons or the or the bonds such as double bond. Then few atoms also absorb it, such as chlorine. Chlorine is also a chromophore. Then sulfur, disulfide bond. These all atoms absorb kind of range from the UV visual range. As you know from the electromagnetic spectrum, 400 to 700 is the visual light. Below it, it is UV light, and after it is infrared. Okay, so basically the UV visual spectrophotometer works in this range, from UV range to visual light range. So here the near UV range, that is from 250 to 400 nanometer. Far UV range is 190 to 250 nanometer. Vacuum UV range is less than 190 nanometer. Now in amino acid, in terms of amino acid, the pi to pi star transition of peptide are shown to have at 190 nanometer, and n to pi star transition, because the peptide bond that I will discuss in the later slides, the peptide bonds tend to have the partial double bond character, and also the lone pair of the nitrogen are delocalizing from its structure. Then they form the partial double bond characteristic, and because of that, you see the you see the absorbance at the 190 nanometer and 220 nanometer. But because the tyrosine, tryptophan, and phenylalanine, both all three have the pi bonds, because they are aromatic. They have the aromatic side chain, right? Aromatic ring of its, they have the delocalization of pi electrons, and when the pi to pi star transition is made, then all three absorbs the light, UV light, in the 280 nanometer, which is in the range of near UV, right? 250 to 400 is near UV range, and in the far UV, you observe the absorbance of peptide chain. So this is very important to estimate the concentration of protein, or to identify whether in your sample the proteins are present or not. So this is a very important phenomena. Now, if in the presence of certain oxochrome, or in presence of delocalization of the electrons, or in presence of certain kind of solvents, these amino acids or the compounds that are chromophores, they exhibit kind of shift, the wavelength shift. Okay, so those wavelength shift is observed because of the delocalization of electron, and if they shift towards the right side, then this is called the red shift or bathochromic shift. This mostly scientists have observed in the bathochromic shift, hydrophobicity is increasing. When the when the absorbance spectrum is shifting towards the left side, this is called the blue shift or hypsochromic. Right, red shift is bathochromic, left shift is hypsochromic, and scientists has observed this phenomena. During this phenomena, polarity is increasing. Okay, so if the absorbance is increasing, then it is the peak is increasing, then it is hyperchromic, and when it is lowering down, that is it is hypochromic. Okay, so you can see that as example, benzene, if nothing is attached to the benzene, then its lambda max is 256 and E max is 250. E is the molar absorptive coefficient. Okay, but in presence of NH2 that is attached to the benzene, NH2 is a oxochrome, then it forms an aniline and it faces a right shift, right? 280 nanometer, right in the this trend is this graph. So this is called, this will be the bathochromic, and in presence of chlorine also it. So these are the examples of it. So the delocalization of electron, effect of delocalization is represented in this here. Now the two important things for UV visual spectrophotometer or the absorbance, to understand the absorbance, you need to remember this law, which is called the Beer-Ambert law, where absorbance or OD is calculated as the multiplication of molar absorptive coefficient, concentration of protein or that particular compound in the solution, and the path length. Path length is normally in the 1 centimeter because we use the cuvette here. Here this is the cuvette, and this is for the 1 centimeter path length. Now, to calculate the epsilon, which is molar absorptivity coefficient, the theoretical estimation is you need, because tryptophan and tyrosine absorbs the maximum in the range of 280 nanometer. So the calculation is done based on that, and the unit of this epsilon is per molar per centimeter. So you will calculate the molar absorptivity coefficient of the protein at 280 nanometer will be number of tryptophan multiplied by the its molar absorptivity coefficient, and number of tyrosine multiplied by the molar absorptive coefficient of tyrosine. Okay, so the solution, now coming to the now these two questions. Now the correct answer for 14 is B. Hypsochromic shift occurs when polarity increases. Okay, to solve the question number 15, which is based on the absorbs. So the question was to calculate the change in pH. So for that, first you need to write down the chemical equation of the buffer. So here your HA was the weak acid. If you dissolve this in the water, which was the 1 ml given there, so it will the HA will donate proton and it will release at the equilibrium. You will have the hydronium ion and its conjugate base, right? The pKa was given here. So Ka was given here, which was 1.75 into 10 raised to minus 5. And you can calculate the pKa based on the by taking the negative of logarithm. Now, what were given in the question? The moles of HA, which is 1 mole, moles of salt of its conjugate base, which is 1 mole again, then volume of solution is 1 liter. Now, to calculate the pH of original buffer, which was the concentration of HA will be the same as its conjugate base because it has only one proton, and based on the law of mass action, it will have the concentration will be both concentration will be same. Then 1 mole divided by 1 liter, which means 1 molar. Then pH will be calculated as pKa plus log base 10 and ratio of conjugate base and ratio of conjugate base and its acid. Okay, then the pH will be pKa plus this one, and you will find the pH is 4.75. The important thing here, you need to remember that here, if the concentration of weak acid and concentration of its base is same, then pH will be equal to pKa, because the conjugate base released and the concentration of acid will be same. So log of 1 will be 0 and your pH will be same as your pKa. Remember this concept. Now, in the next part of the question, they added certain base, which is NaOH, right? So moles of NaOH, the question has given that 2.25 ml of 0.2 molar. So the molarity will be 0.005 molar. Now the volume of buffer that have been taken is 500 ml. So the molarity of that particular buffer will be 0.5 molar solution. Then if you calculate the total, because initially it was 0.5 and 0.5 acid and 0.5 base, the addition of this will neutralize the acid, but it will increase the presence of conjugate base. So now you will have the new buffer which pH will be pKa plus log of this, and then you will find the new buffer pH has increased, which is 4.766. So your changes pH will be approximately 0.00, 0.001 or 0.01. Okay, so your correct answer was D. And now here, so your correct answer is D. And you can also answer the question number 6 here, 16 here. The acid 1 molar and Na. So you blindly just tick the pH will be, the resulting pH will be the equal to the pKa. So correct answer is 4.87 without calculating. Okay. Now coming to your next and last question. Calculate the molar extinction coefficient of 50 amino acid peptide contains the 3 tyrosine and 2 tryptophan with molecular weight of 5.5 kilodalton. Calculate the extinction coefficient and absorbance of 0.1 molar solution of the protein. So here you need to identify which all informations are important for you. To calculate the molar extinction coefficient, you will need the number of tyrosine and number of tryptophan, right? This is extra information which you don't need. You know the molar absorptivity of the tyrosine and tryptophan, so which is 5690, and tyrosine it is 1280. So you can calculate the epsilon of protein, which will be here. Here. Okay. So you can calculate this by formula. Then given number of tryptophan 3, number of this, concentration of protein is 0.1 millimolar. You, for solving any numerical question, you must focus on the units that are given. People tends to make the mistake without overlooking this unit of particular compound given. So here your molar absorptivity of the protein will be 515220 per molar per centimeter, and your absorption will be this multiplied by the concentration of protein multiplied by the path length, and your absorption is 1.522. Okay, so now next question. Resonance structure can be drawn by the peptide bond indicating the peptide bond. Just some statements are given and then options are given. The geometry of the peptide bond is in protein is this is a statement, and then a tripeptide has how many amino acid and how many peptide. So I will go to the discussion of this. First, to that I will discuss the the concept of protein, concept of peptide bond formation. So you need to remember 3 things while the peptide bond formation. One thing, if 2 amino acids are given and you need to form a peptide bond, your first amino acid will be kept in the left hand side, and that will be termed as the N terminal, and your right hand side you will have the C terminal, and that will be your end of the protein. Okay, second amino acid and the end. If another amino acid is coming, then this will be C terminal, and another here the N terminal will come and C terminal will be on the end. So by convention, in the left hand side, you will have the N terminal. So if you are writing a sequence of peptide, then you will have the left hand side, you will have N terminal, right hand side, you have C terminal, and there will be a release of proton. So these three things you need to remember while you are studying about the peptide bond formation. And this is your peptide bond. Now, the angles that are involved in the peptide bond. Normally, in convention, this is your C alpha, right? This is your C alpha, right? So in C alpha C bond, the bond of C alpha and C is termed as psi. So you can remember this by CC psi. Okay, and N and C alpha, bond of N and C alpha will be termed as phi angle. And the peptide bond, the torsional angles of the peptide bond will be denoted as omega angle. Okay. So because the oxygen has two lone pairs here, nitrogen has one lone pair, and the delocalization of this because of resonance of this lone pair creates a partial double bond character, because of which the peptide bond has a 40% double bond character. Okay, because they have the kind of double bond in nature, then they are the in theory they are rigid and planar structure. Peptide bond is rigid and planar structure as a consequence of resonance interaction. Then because it has the partial double bond character, it will have the restricted rotation, but it will rotate. And because of that only, we observe the cis and transformation. Okay, which is observed in the case of proline. Okay, in case of proline, when both C alpha in on the same side, then it is called as a cis formation, cis conformation, and when it is on the opposite end, then it is called as the trans conformation. Okay, now the four atoms that are involved in the peptide plane, four atoms, which are the four atoms? Oxygen, carbon, nitrogen, and hydrogen. They are relatively in rigid plane, which I have already discussed. And then planarity is due to the delocalization of pi electrons over the n, means the this lone pair electron of C oxygen atom and keeping the maximum overlap of the contributing pi orbital. So now I guess you can answer this. You can answer all three questions. The correct answer for 18 will be option C, which means the resonance structure, the peptide bond is stronger than ordinary single bond because it has partial double bond character, and is weaker than ordinary single bond. Stronger than, sorry. This is the wrong answer. So option C is 1 and 2. So is stronger than ordinary single and partial double bond character. Okay. Now geometry of peptide bond in protein is usually, you will only observe the cis formation due to the when proline is present in that. Okay, so your correct answer is option B. For 19, option B is the correct answer. Usually trans even if the proline is the next to amino acids, because cis formation can only happen in the proline. Okay, rest all options are wrong. A tripeptide has how many? For the formation of tripeptide will involve tripeptide. Tri means 3, and peptide bond formation means as I have already told you that formation of a dipeptide will release a proton, will release a water molecule, and then one peptide bond will be created. So tripeptide means one, then peptide bond, second amino acid, then peptide bond, and third amino acid. So it means 2 peptide bond and 3 amino acid. Okay, so your correct answer is 3 amino acid and 2 peptide bond. Okay, so I hope you all are able to understand your understand these questions, and I hope your doubts are clear regarding to the week 1 assignment, and you will be able to submit within time. And this is my information. I have taken the references from this. You can also go through these websites and go through the materials. Thank you, everyone. I hope I was able to answer your queries, and I hope it is clear to all of you. So now I would like to thank all of you for patience listening and attending this lecture. Similarly, I will be taking the sessions for all the week, and I hope you all will join on Friday this time. So if you have any query, you can ask me related to this presentation, or else you can email me on the given email ID karan18@iitg.ac.in, or you can also ask in the discussion forum. So anyone have question, they can unmute themselves and ask. Also note, I will upload this recording in YouTube, and you can watch my channel. I will say this is my channel, NPTEL-PMRF TA NOC22-BT62. Okay, so here I have uploaded the assignment practice for week 0 also, and then I will be uploading the week 1 also. So subscribe this channel for all the upcoming videos, and also you can ask in the comment section also, and your feedback will be feedback will be appreciated. So anyone have question, they can unmute themselves and ask, or else we can rest this meeting now. Any question? Okay. Thank you so much for joining the session. I hope you all will join the next sessions also on the same time, same day. Thank you so much and happy learning.